So we are going to take notes on graphing characteristics. So we've already looked at domain and range and x-intercepts, y-intercepts, starting and ending points. We're going to add another piece to this, which is our asymptote. And you should have seen this in section 122. So what we're going to do is we're going to go through and graph y equals 1 over x minus 7. Again, very similar to what you just did for your lesson for this. So what we're going to do is we're going to pick values of x that make this make sense. So I know if I plug 7 in for x, I don't get a solution. I can't take 1 and divide it by 0. So I know I cannot have an input of 7. So therefore I have to remember that. So x can't be 7. But then I can pick other values that are around it. I can put in 8, I can put in 9, I can put in 10, I can put in 6, 5, 4, etc. All of those are going to give me some points. So when we do this, we get those. Go ahead and pause to put those points in. But what you're going to see as well is at 7, what happens at 7. So what happens at 7.001? So what happens at that x value? What happens on the other side of 7? What happens at this x value, or even closer to 7? What happens at each of those situations? Well, hopefully when you made your table and you looked at the graph, it grew, but never quite reached that value. Now, one of the things that you're going to notice is I did count by tenths on my graph, just because I knew it was 1 divided by a number, so my numbers are getting small. So I know the closer I get to 7 from the left-hand side, this keeps going down. That's a really bad curve. This way. There we go. That's not so bad. So it keeps going down. And what happens when I put in 6.9? 6.9 is negative 10, right? 6.99 is negative 100. 6.999 is negative 1,000, etc. It's going off to negative infinity. But when I'm coming closer to 7 from the right-hand side, it's shooting up to positive infinity. So if I put in 7.01, I get 10, positive 10. If I put in 7.001, I get 100, etc. Never can I get a value when x is 7. But I can get a value up top here and down low here. So that's what happens really close to that 7 value. That 7 is called an asymptote. So when x equals 7, that is a vertical asymptote. Because at 7, it's shooting up to infinity or down to negative infinity. They could both go up to positive infinity. They could both go down to negative infinity. But I also have something else. If I look at what happens when I put a really big number in, what happens at 10 and 11 and 12 and 13 and 14, etc. So the bigger number that I put in here, I'm just subtracting 7 from it. So what if I put a million in there? So it's 7 less than a million. What's 1 broke into 7 less than a million? Like if I took a whole pie, that's what the 1 represents, and I break it into pretty much a million pieces, how much pie are you going to get? Pretty much 0, right? But do you still get pie? Technically, yes. But it's really, really close to 0. So what happens here is this is going to level out. I can put a billion in for x. I can put a really, really big number in, and it gets closer and closer and closer to 0. The same thing happens on the left side of my graph. What happens if I put negative 1 in? It's going to be a number that's small. What if I put in negative 2, negative 3, negative 4, negative 5? What happens when I put those values in? What if I put in negative a million? I take 1 and divide it by negative 1,000,007. I get a negative number, but it's pretty much 0. So this also approaches 0. That is called a horizontal asymptote. There is a horizontal asymptote at y equals 0. Again, that's at the ends of your graph because my graph is approaching a number. In this case, it's 0. We have a vertical asymptote when it's shooting up to positive infinity or negative infinity. I have a horizontal asymptote when it's going out towards those values. Okay, a couple other graphing characteristics that I want you to put in your notes would be your x-intercepts. Now you can see on your graph, and we talked about it, no matter what, I can't take 1 and divide it by something and get 0 out. Okay, it's not possible because that's all that's happening in this problem. Therefore, I don't have any x-intercepts. And in this case, my y-intercept, think about what y-intercept means. The y-intercept is the value of y when x is 0. You're trying to find that y value. You're trying to find where does it cross right here. So therefore, I make x 0. If you aren't sure what either of those intercepts are, at some times you're not going to know them, plug it into the equation. So what do I get when I plug it in there? Negative 1/7. You don't have to find the decimal. I don't care what the decimal is. Domain. Let's look at our domain. So we practiced this the other day. Domain are your x values. So what values of x can you have? Can you have a bunch of positives? Yes, except for 0. I'm sorry, except for 7. Can I have a bunch of negatives and 0? Absolutely. So my domain is all real numbers except x cannot equal 7. And then my range are my y values. So I go up and down. Do I have positive numbers? You betcha. Do I have negative numbers? You betcha. Do we have 0? No. So when you're looking at your range, you've got to look at, well, where is that asymptote at? So for your range, it's all real numbers except y cannot be 0. The last thing that I have to put in here is I listed my asymptotes, but I do have to show that graphically. So to show that graphically, all you need to do is you need to use a dotted line. Just getting all the extra stuff out. So the asymptote, we show by putting a dotted line wherever it happens. So since I have a horizontal asymptote at y equals 0, at the equation y equals 0, I put a dotted line. And then since I have a vertical asymptote at x equals 7, I put a dotted line at x equals 7. And that way we know that it isn't just going to do something else. It's not going to like bounce back up, because that can happen with graphs. We do know that there is an asymptote there. Okay, and then the last piece that we can do, because there is a horizontal asymptote, so the last graphing characteristic we're going to look at is called end behavior. And you will be putting these, you'll be writing these out for the different functions that we do. So end behavior goes as follows. End behavior is what happens at the ends of your graph. Remember, our graph is controlled by our independent variables, which are our x's. So therefore, our end behavior for this is as x approaches infinity. So that's the notation. X arrow infinity means as x approaches infinity, let's look at our graph. So as x gets really, really big here, what's my y value doing? This value here, my y, is getting closer and closer to 0. So y approaches 0. If you want to get fancy, it's approaching 0 from the top side, so you can put a superscript of a plus. You won't have to do that till you get to pre-calc. But as x approaches infinity, y approaches 0. And then there's two ends of this graph. There's another arrow over here. It keeps going. Oh, as x approaches negative infinity, so as x approaches negative infinity, again, we always start with x. That's our control. Y approaches 0 as well. This time it's approaching from the negative side. Again, I don't really care that you put the superscripts of the plus and minus there. What I do care about is your end behavior. We'll start you off with these. So we'll start by giving you the initial part of the end behavior. You're going to have to do the final. So we'll start with as x approaches infinity, comma, you'll have to fill in the y approaches 0. And we'll start you with as x approaches negative infinity, you'll have to write y approaches 0. Eventually, you'll be able to do all of them. So with this new function, you now know how to do, or how to look at vertical asymptotes, horizontal asymptotes, and now we added end behavior.